Welcome back to Inquisitive Kids. This video is part 2, a continuation of what we learned in our last lesson. It's called the composition of translations. In our last lesson, we learned about basic translations, and we saw how coordinates can change as we translate a point or figure. Our main learning goal for today is to understand and master the conversion of translations on a plane and the change of coordinates through a translation. In the coordinate system, how will the points move when the coordinates are changed as follows? If y is added 4, it means we are moving a point up 4 units. Y minus 2 means we are translating 2 units down. X minus 1 equals we're translating 1 unit left. X plus 3 means we're translating 3 units to the right. This is a quick review on what we learned in our last lesson. Now I want you to think about it. What would happen if we have x minus 3, y plus 4? Well, here we start off with a x, y. We first translate left 3 units to get x minus 3y, and then we still have to translate one more time to get x minus 3y plus 4 by translating it up 4 units. As you can see, we broke this down into 2 smaller steps, only changing one coordinate at a time. Here we have point A. Point A is translated down by 2 units and then translated to the right by 3 units to get A prime. Can you find the position of A prime? First, you just go down by 2 units and then go to the right by 3 units to get 5, negative 1. This is where A prime should be. Can you think of any other ways to translate this point? And can point A translate to point A prime through just one translation? If yes, indicate the translation direction and distance. Well, instead of going down first and then going right, you could first go right and then go down. And how would you find the translation distance? Well, the distance would be from A to A prime, line segment A prime. How can you find the length of that? Of course, since this is kind of a diagonal, we can always use the Pythagorean theorem. You can see here that it is expressed as a right triangle. Observe the coordinates of points A and A prime. What values changed? A is 2, 1, and A prime is 5, negative 1. The x coordinate and the y coordinate both changed. The x coordinate increased and the y coordinate decreased. Here we have a so-called fish, and I want you to translate it down by 2 units and then to the right by 3 units to get a new fish. Draw the new fish on the Cartesian coordinate plane. First, you translate it down by 2 units and then to the right by 3 units. Or you can first translate it to the right by 3 units and then translate it down by 2 units to get this figure. Now it's asking you, what is the distance this entire figure translated? What is the distance from O to A since they are corresponding points? Again, you would have to use the Pythagorean theorem. Length is 3 units, and this length is 2 units. So 3 squared plus 2 squared equals this black line, OA squared. And then all you have to do is go ahead and solve. What is the direction and distance of the previous translation? So the direction was from O to A, and the distance is OA, which is the arithmetic square root of 13, because we use the Pythagorean theorem. What is the relationship between the coordinates of the corresponding points? Well, all you had to do was add 3 to the x coordinate and then subtract 2 from the y coordinate. Now I want you to add 2 to the x coordinate of each point on fish F, and then add 3 to the y coordinate of each point on fish G to get fish H. What is the change in position between F, H, and the original fish F? Here's an animation. We start off with fish F, and then we translate it to the right to get fish G. And then you have to translate fish G up to get fish H. This is basically a step-by-step solution of how to translate a figure diagonally. First, you can move it along the x-axis and then the y-axis. What is the distance of the previous translation? The shape and size remain the same, but the position changes. The figure is first translated to the right by 2 units and then moved up by 3 units. So then you can use the Pythagorean theorem. 3 squared plus 2 squared equals the distance squared. So the translation distance is the arithmetic square root of 13. What is the change in position after a figure is translated along the x and y axes at the same time? So when you move right a units and move up b units, it would be expressed as this. When you move right a units and move down b units, it's x plus a, y minus b. When you move left a units, move up b units, it's x minus a, y plus b, and so on. You get the idea. Example 1. The coordinates of the vertices of the quadrilateral ABCD are A, B, C, D. ABCD is translated upward by 3 units and then translated to the right by 4 units to get quadrilateral A prime, B prime, C prime, D prime. What is the relationship between the x-coordinates of the vertices of A prime, B prime, C prime, D prime and the x-coordinates of the corresponding points on ABCD? So right now we're only focusing on the x-coordinates. The problem says that this quadrilateral was translated to the right by 4 units, which means that all of the x-coordinates must have increased by 4 units. And these are all of the new coordinates. Number 2. What is the relationship between the y-coordinates of the vertices of A prime, B prime, C prime, D prime, and the y-coordinates of the corresponding points on ABCD? Now, what changed with the y-coordinate? Well, this quadrilateral was moved up by 3 units, which means that the y-coordinate also increased by 3 units. If quadrilateral A prime, B prime, C prime, D prime was obtained by a translation of ABCD, indicate the direction and distance of this translation. You can actually connect any 2 corresponding points you want. In this case, we connected A and its corresponding point A prime. So all you have to do is find the length of line segment A prime. And you can use the Pythagorean theorem to help you. So that would be 5 units, which means that the translation distance is 5 units. And the translation direction is from A to A prime. Class summary. Today we learned about the composition of translations. We learned that we can first translate along the x and y axis separately. And that's the same thing as just translating it once diagonally. I hope you enjoyed this video and be sure to come back for our next lesson.